There are days in space science when the comfortable safety of our models simply evaporates. Usually, orbital mechanics is the most precise discipline we have. We know where a planet will be in 1,000 years down to the meter. We know how a comet behaves when it falls toward the sun. But today is one of those days where the math has stopped working. Interstellar Object 3I Atlas has shifted again. This isn't a small wobble. This isn't a rounding error in a spreadsheet at NASA. This is a significant, measurable deviation that has pushed the object completely outside its predicted path. Whatever this traveler is, it is not behaving like a comet. It is not behaving like a standard asteroid. And it is certainly not obeying the rules we thought governed gravity in the inner solar system. The update came through just under an hour ago. Independent observation pipelines from ground-based surveys and orbital relays all started flashing the same warning at the same time. The object changed direction. It was a slight movement at first, barely a fraction of a degree, but in the vast geometry of interplanetary space, a fraction of a degree translates to tens of thousands of kilometers of difference. And that gap is widening by the second. This marks the fourth significant deviation recorded since late September, and the second time it has moved unexpectedly in just the last 72 hours. Every time it shifts, the natural explanations become harder to defend. We are looking for a cause. The shift today appears to correlate perfectly with the timing of a surge in solar activity. A coronal mass ejection, or CME, has been dispersing charged particles across the heliosphere, and it slammed into the region where 3I Atlas is traveling. But here is the problem: correlation does not imply causation. If this were a simple case of solar wind pushing against a dusty comet, we would see evidence. We would see a sudden brightening as the coma flared up. We would see a tail burst as material was stripped away. We would see a rotational plume acting like a thruster. Instead, we see nothing. The coma remains nearly uniform, unusually featureless, and oddly compact. It still displays that baffling sunward anti-tail, the signature that continues to haunt every researcher trying to model this thing. It absorbed the impact of a solar storm and simply changed course without shedding the mass that physics says it should. Right now, the situation is becoming critical because 3I Atlas is approaching its minimum solar elongation. In plain English, that means it is getting too close to the sun from Earth's perspective. It is lost in the glare. Ground-based astronomers are effectively blind. We can't point our telescopes at it without frying the sensors. The timing could not be worse. Just as the object decides to make its most radical move, a major government freeze has paused several public-facing data channels. We are staring into the sun with one eye closed and the other one blinded by bureaucracy. Yet, in this silence, a few robotic eyes are still watching. Mars is currently the front row seat for this event. Several spacecraft orbiting the red planet, along with rovers on the surface, have been gathering data as 3I Atlas sweeps through its nearest approach. Just yesterday, a sequence of images taken from the Martian surface showed something extraordinary: a fast, linear streak cutting across the sky, persisting across multiple frames. We analyzed the exposure smear. It doesn't match the rotation of Mars. It doesn't match the movement of stars. It aligns perfectly with the velocity vector of the interstellar object. This implies we have a genuine visual confirmation from the surface of another world. Based on the brightness and the angular velocity recorded by the rover, we can now estimate the nucleus is at least 5 kilometers wide. That makes it one of the largest interstellar objects ever imaged within our system. But this size estimate makes the latest shift even more baffling. It is basic physics. Massive objects are hard to move. If you have a 5-kilometer wide rock, you need a tremendous amount of force to alter its trajectory. If that force comes from outgassing ice turning into steam, you would see a massive cloud. We don't see it. So, How does a mountain-sized object change direction without a visible engine? Models attempting to fit this new trajectory are breaking down. They require either a highly uneven, deeply buried jet of sublimating material that somehow produces thrust without generating a visible plume, or they require an internal structural process that does not resemble thermal outgassing at all. We have to go back to the timeline. There was a position anomaly after the CME impact, then a minor correction on September 27th. A larger drift was detected on October 2nd, and now this measurable shift today. Comparing the predicted path to the actual path is like overlaying two different maps that no longer agree with each other. This is not chaos. Chaos is random. This feels almost responsive. It is behaving less like a passive icy body falling through gravity and more like something that is interacting dynamically with its environment. The European Space Agency has scheduled multi-instrument observations today using the Mars Express and the Trace Gas Orbiter. These are critical because 3I ATLAS is temporarily closer to Mars than to anything else. If any mission is going to capture a high-resolution view of the nucleus, it will be one of these. But even that is uncertain. If the object continues to shift even slightly, the instruments have to compensate in real time. Automated pointing solutions assume predictable motion. 3I ATLAS is no longer predictable. If the camera points where the math says the object should be, it might photograph empty space because the object has moved. Later this month, if the orbit holds, 3I ATLAS will reach its perihelion, its closest point to the Sun, accelerating to nearly 68 kilometers per second. That speed, combined with the intense heat, should cause any normal comet to expand significantly. It should grow a massive tail. It should become a spectacle. But this object has defied that expectation repeatedly. Instead of growing, it remains compact. The anti-tail shrinks and expands at unpredictable intervals, like a breathing lung rather than a melting ice cube. We are also looking ahead to ESA's JUICE spacecraft, which is expected to begin observing it in early November. However, due to line of sight constraints with the Sun blocking communications, that data might not reach Earth until early 2026. Imagine the frustration of having the answers sitting on a hard drive millions of miles away, unable to download them while the mystery deepens here on Earth. China's Tianwen-1 orbiter is another asset that could theoretically track it, as is the UAE's HOPE orbiter. If all these agencies collected data and shared it, we would have a dataset unparalleled in history: spectroscopy, ultraviolet signatures, infrared structure, plasma interactions. We could finally classify this thing. But as of now, the silence from the major agencies is deafening. There is a disturbing parallel here to Oumuamua, the first visitor we saw in 2017. Oumuamua also showed non-gravitational acceleration. It sped up as it left the solar system. But Oumuamua was small, tumbling, and dim. 3I ATLAS is larger, brighter, and far more aligned with the ecliptic plane, the flat disk where all the planets orbit. That alignment has raised eyebrows since July. Interstellar objects should come from random directions. They shouldn't slide perfectly into our orbital plane like a car merging onto a highway. And while Oumuamua remained directionally stable, 3I ATLAS appears to be updating its trajectory piece by piece, as though something internal is constantly adjusting how it interacts with the solar wind. The next few weeks will be decisive. As soon as the object moves out of the sun's glare, there will be a rush to reacquire it from ground stations. But until then, we are relying on Mars. We are relying on robotic explorers designed to look at red rocks, now forced to look up at an interstellar enigma. This is not the moment anyone wanted to experience: a shifting trajectory, a government freeze, and a blinding sun all happening at once. Yet here we are. The goal now is to gather every available frame. Whether 3I ATLAS is a highly unusual natural body or something we have not yet categorized, the science demands clarity. For now, the trajectory is being updated hourly. The shift is real. The cause is unknown. And the situation is evolving faster than our models can keep up. Every instrument still operating is watching for the next update. Until we get that data, the only responsible position to take is this: 3i Atlas is not behaving like any ordinary object. It has shifted again, and the implications of that shift are widening with every passing second. We are watching a mystery unfold in real time, and it is getting out of control. 3i Atlas just sidestepped again. This is getting out of control